In this video, we're going to look at another example of areas between curves. Let R be the region bounded by the graph of y equals x, e to the minus x, and the x-axis, which is y equals 0, on the interval b to infinity, where b is a constant. Find the value of b such that the area of the region is 2 over e. Now, this is an inverse type of question. Usually, they ask us to find the area. But in this question, we're given the area to be 2 over e, and we have to work backwards and find the value of b such that the area is 2 over e. Like usual, we will start with a sketch. And here's the sketch. Y is equal to x e to the minus x. And if we draw a typical rectangular slice, this is going to be dx is the width. And the height is x e to the minus x. And this is the area of one of these slices. The area of one of these slices is differential area, dA, is equal to x e to the minus x dx. And then we add up all these vertical rectangular slices in the x direction, and we find the area. That's what the integral basically does. It adds up all these rectangular slices. All right, so let's look at setting up a definite integral and solving for b. So the area is the integral from b to infinity, x e to the minus x dx. And this area is equal to 2 over e, and we have to solve for b. Notice this is an improper integral. Why is that? The reason is because the upper limit of integration is going to infinity. So the strategy we're going to employ here, looking at the integrand x e to the minus x, U substitution will not work. We're going to apply integration by parts. Integration by parts. And the formula is integral a to b u dv is equal to uv evaluated from a to b minus integral v du integrated from a to b. So we're going to let u be the polynomial, let u equals x, differentiate both sides, we get du is equal to dx. So this part is u, and the remainder is going to be dv, whatever is left over. dv is equal to e to the minus x dx. Integrate both sides, and we get v. So v is going to be, what is the antiderivative of e to the minus x? We have to use the U substitution method. That's going to be e to the minus x divided by minus 1. I'll put a negative in the front. All right, so we get u times v, which is going to be, so the area is equal to u times v. U is x times v, which is minus e to the minus x, evaluated from b to infinity, minus integral v du, which is minus e to the minus x, times du, which is dx, from b to infinity. So area is equal to minus x, e to the minus x, from b to infinity, minus minus is plus, integral from b to infinity, e to the minus x dx, and this area is equal to 2 over e, and our job is to solve for this value of b, for this b. All right, let's do that. So what we have is area is equal to minus x, e to the minus x, from b to infinity, evaluated from b to infinity, plus the integral from b to infinity, e to the minus x dx, and this area is equal to 2 over e. All right, so let's do the mechanics of this. We get minus x, e to the minus x, plus, what is the antiderivative of e to the minus x? We already found this when we were integrating dv. Recall dv was e to the minus x dx, so v was minus e to the minus x. So we're just going to apply reversal of the chain rule, or U substitution is going to be e to the minus x divided by minus 1. We can just write it as minus e to the minus x. And evaluate it from b to infinity, that's equal to 2 over e. But because it's an improper integral, we have to apply formal notation. So the area is equal to limit p goes to infinity, and we're going to have minus x, e to the minus x, minus e to the minus x, from b to p. So replace infinity by p. Then, of course, we take the limit as p goes to infinity. And this result should be equal to 2 over e. So area is equal to limit as p goes to infinity. Now put the upper limit in, and we get minus p, e to the minus p, minus e to the minus p. Subtract the lower limit, minus b, e to the minus b, minus e to the minus b. And this result is equal to 2 over e. All right, so now let's distribute this, and we get area is equal to distribute the limit, that is, limit p goes to infinity, minus p, divide by e to the p, minus 1 over e to the p. Notice we wrote it as a fraction, and you will see why. Plus b, e to the minus b, plus, distribute the minus sign, minus is plus, plus e to the minus b. This result is equal to 2 over e. And the limit is applied to this expression that involves p. Now, it's important to realize that this ratio, p over e to the p, approaches 0. Why is that? Also, this ratio, 1 over e to the p, as p goes to infinity, approaches 0. Why is that? Here's the reason. We know that the exponential function rises a lot faster than a linear function p. So therefore, as p goes to infinity, the ratio, the limit of this ratio, p goes to infinity, of p over e to the p, this ratio approaches 0. Similarly, the limit as p goes to infinity of 1 over e to the p is 0. Because in the numerator, you just have the constant 1. In the denominator, you have the exponential function that's approaching infinity. So you get 1 over infinity, that ratio is 0. So this is 0, and this is 0. So we're left with area is equal to limit. Let me rewrite that. P goes to infinity minus p divided by e to the p minus 1 over e to the p plus b e to the minus b plus e to the minus b. The result is 2 over e. And we showed that this ratio is 0, and 1 over e to the p, this ratio is also 0 as p goes to infinity. So if we simplify this, we get area is equal to b e to the minus b plus e to the minus b is equal to 2 over e. Now I'm going to simplify this a little bit. Let's factor out e to the minus b and write it as 1 over e to the b times b plus 1 is equal to 2 over e. Now we can't use algebra to solve the above equation. So we have to be a little bit crafty about this. We're going to guess by inspection. And usually the questions have been constructed such that it's easily guessable. Otherwise, you have to use a computer to solve it. So looking at this, why don't we try b equals 1? There is our idea. And let's check it out, see if it works. Area is equal to 1 over e to the 1. Area is equal to 1 over e to the 1 times 1 plus 1. And what is this equal to? 1 plus 1 is 2. 2 over e equals 2 over e. Yes, that works. So what we have found is if b equals 1, the entire area from b to infinity, x e to the minus x dx, is equal to 2 over e. So we found the value of b. Let's replace that. Put 1 here. And if you were to integrate this, you will get exactly 2 over e. All right, thanks.